Come back again with a new short video about geomechanics. Today we will talk about earth stress. Here is the world map stress, one of the indicators of the stress state over the earth crust. The world map stress is the worldwide database of the stress orientation. However, the most data used in the world map stress are from earthquakes in the flat boundaries. At regional scale, measurements are not abundant due to confidentiality of the input data for petroleum companies. For example, well logs, seismic data, and frac measurements. But recently, we can find some published paper about stress orientation that can be used as reference for the area of interest. The fundamental law used in the stress analysis is the famous law of Anderson, which stated that the stress response of the Earth crust to a stress in a surface or a volume can be explained by three stress faulting regimes. The normal faulting due to an extensional stress, the strike-slip faulting regime where the overburden stress is the second stress mean that the maximum horizontal stress is the principal stress, and the reverse faulting, where the vertical stress is the least stress, which is a critical state of stress. We found this kind of regime in the active seismic area, where the area receives loading from horizontal direction, for example, the northern part of Algeria, especially in the eastern part. In the local scale, we can find stress regime changes from one regime to another. For example, we can go from normal to strike-slip or from reverse to strike-slip. So here we can talk about normal to strike-slip regime or reverse to strike-slip regime. But it is rarely found that we pass directly from normal to reverse. Be careful, it is very dangerous and requires a lot of stress load that can cause a big earthquake. So, by definition, Anderson has defined the stress with three components: the vertical components and two horizontal components. In most time, the principal component is the vertical component. We say that most time, not all the time. You can see this in horizontal drilling for unconventional and tight reservoirs. And two horizontal components, which are the maximum and minimum horizontal stress. Why? It is very simple. The vertical is due to upper mass layer, and the two horizontal due to stress load from local and regional force acting in the area. You should also know that the stress load can be transmitted from active zones to non-active seismic zones. And this is a lot of examples about this. For example, transmission of the stress from the Eurasian African edge to the Saharan platform, Algeria. That's all for today. I hope that this short video was beneficial for you, and see you in the next short video about another topic of petroleum geomechanics.